Welcome back, Math Nines. Mr. T here, and we are going to do a really important lesson where we're going to discover our our first two exponent laws. Okay, we actually do have one so far. We do have the zero exponent law, which anything raised to the power of zero is one. But we're going to look at ones that are a little bit more complicated. Well, really, they're not that complicated. Let's be honest. Once you see this, it's going to make a lot of sense. But ones that we use a lot more often. Okay, so we're going to discover these with a little bit of recognition of patterns. So over here, I have a product of powers in this column with the same base. Well, product means I'm multiplying. Okay, and I have powers. So in this case, I have 5 to the 4 is a power, 5 to the 2 is a power. Okay, and they have to have the same base. They both have 5s as their base. So if it meets those requirements, we're going to discover a special law we can use to make our life go let our math life go a lot faster and easier. So what does this represent? We're going to write it as repeated multiplication here. And so first, 5 to the 4, that means I'm multiplying 5 by itself 4 times. So 5 times 5 times 5 times 5. Okay, so that's the first 4 5s there. And then I'm multiplying it by 2 more 5s. Okay, I never want you to write it this way when you're working on things because, well, we have calculators, but I really want to show what's actually happening here is 5's being multiplied by itself 6 times. So this would be the exact same if I wrote it as a single power is 5 to the 6. All right, we'll come back to this in a second. Let's look at a couple more. Now I have -2. Remember, if there's nothing written here, there's a 1. Okay, there's a hidden exponent of 1 if nothing's written there. So first I have 1 -2, and that's being multiplied by 3 more of them in the second power. Okay, again, I have 2 powers being multiplied, okay, and they have the exact same base of -2. So now in this case, I can see, oh, this is -2 being multiplied 4 times in total. Last one here, I got 3 powers this time being multiplied. Okay, so a product again, but I first have 4 3's. So I'm going to try to make this all fit. And that's being multiplied by 3 more 3's. And then 2 more, 3 times 3. And now, again, this is just 3 being multiplied a whole bunch of times. Well, how many in total is 4 plus 3 is 7 plus 2 more. I have 3 being raised to the power of 9. Now, 2 says here, what rule can you create to reduce a product of powers? Remember, multiplying powers that have the same base, okay, to just a single power. How can I skip from column 1 to column 3? Skip all this extra work in the middle. And it's actually really simple. You might already see it. The idea here is that we'll just look at the exponents. 4 plus the 2. If I add them together, okay, I get 6. Which makes sense. This is saying I have 4 5's being multiplied plus 2 more 5's being multiplied. So in total, I have 6 5's being multiplied. Same thing here. I have 1 -2, and then I'm going to add 3 more -2's. So I'm adding the exponents to say, well, in total, that's the same as saying 4 -2's being multiplied. Last, I have 4 3's plus 3 more 3's plus 2 more 3's all being multiplied, which is represented in the middle column. But we can skip that step and just go right to 9. 4 plus 3 plus 2 is 9. So what's our law? What's our rule? We just have to add exponents. That's it. And then we can write it as a single power. Number 3. What about when we're dividing? So exact same thing. Quotient is a big fancy word for division, and they're powers again, but they must have the same base. Okay, so in this case it's 5's, in this case -2, in this case it's 4's. So let's see what this looks like with repeated multiplication. Um, which essentially means, and we don't really use this division symbol anymore. I want you to get used to writing things as fractions because this is division. It's the exact same thing. So this means I got 5 5s being multiplied in the numerator up top. Okay, so 5 times 5 times 5 times 5 times one more 5. And then on the bottom, I have 3 5s. 5 times 5 times 5. Again, this is a really long way to write this, but we actually discover a really quick way to simplify this. What it's saying is, if I were to break this into just looking at, hey, 1 5 on top, 1 5 on the bottom. Well, what's 5 divided by 5? Anything divided by anything is always 1. Okay, 5 divided by 5. 5 divided into 5 equal groups. Well, each group has 1. So we can divide 1 5 with 1 5 down below to give me a 1. And then I can do it again. 1 5 with 1 5 to give me another 1. And 1 5 with 1 5 to give me another 1. Now I'm all out of 5s on the bottom, which means I'm done doing the cancellation, or 5 divided by 5. So I just have 2 5s left over. And when I do that, let's go back to blue. I just have a single power of 5 times 5, or 5 squared, 5 to the 2. All right, let's do another one. We'll come back to that just like before. You might already see the pattern already. -2 is being multiplied 3 times. Okay, and then on the bottom, it's being multiplied twice. And again, we can use the method of cancellation. -2 divided by -2 is +1. -2 divided by -2 is +1. And 1 times anything is the same thing. So I'm not going to write the ones this time. All I have left is 1 solo -2. So if I were to write that as a power, because there's only one of them, I take the whole thing, put it in brackets, and write it to the 1. All right, let's do one more. I hope you see the pattern now. I got 7 4s this time. So 4 times 4 times 4 times 4 times 4, that's 5. And let's do 2 more. And yeah, that's 7. And then I got to put 4 4s on the bottom being multiplied. All right, now let's divide these things, which just means let's do some canceling. It's always one of my favorite things to do in math because it just makes things faster and more simple. Well, how many 4s do I got left up top? Just 3. So this is the same as saying 4 to the 3. All right, what was our pattern? Let's go to green maybe. Well, when I'm dividing, okay, powers with the same base, what happens if I just subtract the exponents? If I take the 5 5s up top and subtract a 3 on the bottom, so I have 5 5, subtract 3, that's what's happening. I've canceled 3 5s. Here's what I did in red. So 5 minus 3 gives me 2. All right. And then let's try it here. Well, I have 3 and 2. So take your exponents. 3 subtract 2. And that's going to give me 1. 3 minus 2 is 1. And finally, 7 minus 4. Subtract those, and you get 3. So we can skip all of these steps. It's really important to understand what's happening in the middle here. This canceling in fractions, we are going to do a lot of it. You will do it in Math 10, 11, 12. Every math, workplace, calculus, doesn't matter. You will do this technique of canceling to 1, dividing to 1 in fractions. So what's our rule? Pretty clear. We subtract. So there's another law, subtract exponents. Which makes a ton of sense because, well, when you are multiplying, that's the same as repeated addition. So we're adding exponents. We're adding up all of our groups of 5s. I have a group of 4 and a group of 2 to have 6 groups of 5s being multiplied. Then when we subtract, well, division's the same as repeated subtraction, so we're just subtracting exponents. So let's do this question. and it looks complicated. And if you did BEDMAS here, you would get absolutely huge numbers to deal with. But with exponent laws, I see that this is the same base everywhere. It's -7 just being multiplied, different amounts on top, different amounts on the bottom. And remember, there is a 1 right here. So how do we deal with this? Well, really easy actually. I just take my -7 and let's focus on just simplifying the numerator. So I can place brackets here and here, and then we'll simplify our denominator. So -7, I have 10 of them, but let's use our law. Let's add the other exponents. I have 6 more plus another 1. And on the bottom, let's do the same thing. I have 13 plus another 2. So let's rewrite this. Let's actually add up our exponents using our power law, or our product law is what it's going to be called, is -7 raised to the 10 plus 6 plus 1 is 17. And that's being divided by -7 to the 13 plus 2, which is 15. These, again, are huge numbers if you put them in your calculator. But we see that now I have division. I can use that quotient law where we just subtract the exponents. So I take my -7 and I can subtract 17 and 15, which is really easy subtraction. Now I have -7 raised to the power of just 2. It doesn't say to evaluate, it says write as a single power. So that is my final answer. If it said evaluate, we'd get 49. -7 times -7 is 49. All right, here's our laws. Put it in a box. And all this is saying, A and A saying that this is the same base. We are multiplying. And when we do that, we just have to add the exponents to write it as a single power. When we are dividing, and also I want you to write that in fraction notation, A to the M divided by A to the N, we will subtract the exponents. That's what we just saw above. We did it the long way, but now we don't have to do it the long way anymore. We can use these laws to solve these questions very fast. So here I have a product, I have multiplication. So we're going to use our laws. Let's look up here. Okay, I have same base of -2. They're raised to the power of 3 and the power of 2. So I'm going to add exponents. So all I'm doing here is I take my base and I take my exponents, and because we're multiplying these powers, we're going to add exponents. So that gives me -2 to the 5. And so I've simplified, and now I have to evaluate. Always do it in that order. -2 times itself 5 times is -32. Let's move on. This is division again. So this again can be written as 9 to the 10 over 9 to the 9. I could write this out the long way and cancel all the 9s, but we know with our law, we just got to subtract these exponents. 9 to the 10 minus 9, which is just 9 to the 1, and evaluate that. It's simply just 9, because there's only one 9. There's nothing else to multiply. Next here, we have to use both laws. So up above, I'm going to put some brackets because I want to put these together. The same bases everywhere. Everything is a 3. And then I have to deal with all my exponents. So first, I'm going to add these exponents because we're multiplying here. We're multiplying these. So I can go 3 to the 2 plus 4 is 6. And put that over 3 to the 3. And then now I can subtract. 6 minus 3 is 3. So I have 3 to the 3 now. And then multiply that out. 3 times 3 times 3 is 27. Let's do D. Almost done. Write the little 1 here that's missing. Just remember, if there's nothing there, there is an exponent of 1. And now this is pretty straightforward. It's just 3 -3's being multiplied, then another one, and then 2 more. So we're just going to add these exponents. So -3 to the 3 plus 1 plus 2, which is equal to -3 to the 6. We have 6 negatives, so it's going to be positive overall. And if you put that in your calculator, you're going to get 729. Again, positive. Okay, sorry about the typo here. This should say E and this should say F. Regardless of that, take a look at these two. They're different than all the ones we've done before. And what has happened is because we have addition here and subtraction, we have same bases, we have two powers, but there is no law that we can use to quickly combine these powers when there's no multiplication or division. It's addition and subtraction. There is no law. So here and here, this is basically saying do not, okay? So I'm going to just draw a couple arrows here. Same reasoning. Can't use exponent laws, okay? Because it must be a product or a quotient. So what do? You actually already know. It was in the last lesson. All we got to do is BEDMAS. So in this question, I have to do exponents first. So just go back to good old BEDMAS, okay? And these numbers aren't too big. It won't be too bad. So 4 to the 2, so we're going to do that. 4 times 4 is 16. And we're going to add 4 to the 3, which is 64. Add those up together, and you're going to get 80, and you're done. Over here, again, I have to do exponents first. 2 to the 6 is 64. And then I'm going to subtract the 2 to this 4, which is going to be 16. And finally, our answer is 48. All right. So that concludes this lesson. What did we learn? Super quick recap as always. We did some experimenting, some investigating, so to speak, to make a pretty good conjecture here, a good estimated guess that, hey, look what's happening. If I write this out the long way, every time I'm adding exponents when I multiply powers of the same base. And then when I'm dividing powers of the same base, I'm just subtracting the exponents. That's the green arrows here. And then we tried that with a few examples. We had a very complicated one that looked a little bit daunting, but it really wasn't. We added exponents on the top and the bottom, and then we subtracted when we divided. Finally, we were given our laws in a table, and we did 6 more examples where we used our laws, sometimes both of them, sometimes one of them, and then we saw these sneaky questions that teachers love to give where you can't use your law even though it looks like you can't because of the addition and the subtraction. Okay, that's it, that's all. We'll see you next time. Have a good one, everybody.